Hi everyone, I'm Aneesh, the founder of DevVoid, and today we'll be in the episode 7 of DSA AI. So without further ado, let's just look into the problem and get started, shall we? So here are the list of problems that we solved previously. Contains duplicate, valid anagram to sum. Today we'll be looking into best time to buy and sell stock. What we'll do over here, let's look at the problem and let's start reading through it, okay? You are given an array, prices, where prices of I is the price of the given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. You cannot achieve any profit, return 0. Okay? Let's say the stock only keeps decreasing. That time when you can't get any profit, right? So 0. Now, our goal is to add an algorithm to do this, right? So, okay. So let's just see now. Okay. So I'm like 7, 1, 5, 3, 6, 4. This is the input. And the output we need to get is 5 for this one. What's the logic? Let's look into it. But just to make sure you understood the problem, this is the stock prices and 0 day, first day, second day, third day, fourth day, and fifth day in a time series. The stock price is 7 in the first time, 1 after that, then 5, and then 3, and then 6, and 4. And so it's fluctuating a lot, right? Now, our goal is to maximize our profit. So we ideally, if you look at this, you can buy on the first day for 1 and then sell on the fourth day for 6. So you get a profit of 5. That is our output. Okay. Buy on the first day, sell on the fourth day. First means for index 1. Okay. 0 day means index 0. Okay. Now, our final price is 6 minus 1. So it is 5. And that is the required output that we got from a very simple logic that we thought of just now. How did we get those numbers? That's the algorithm I did find for. To begin with, let's do a brute force approach, a very simple approach. Okay. So we'll take the values 7, 1, 5, 6, 3, 4. What are all the combinations of days I can buy and sell this in? So I can do 7, 1, 7, 5, 7, 6, 7, 3, and 7, 4. Right? Then I can do 1, 5, 1, 6, 1, 3, 1, 4. Then I can do 5, 6, 5, 3, 5, 4. Then I can do 6, 3, 6, 4. And finally I can do 3, 4. So if I find a difference here, which should be sell minus buy. So it's actually 1 minus 7. So it is minus 6. This will be minus 2. This will be 7, that is, okay, not 2. So it will be minus 1. This will be minus 4. This will be minus 3. This will be 4, 5, 2, 3. This will be 6 minus 5. So it will be 1. Then this will be minus 2. This will be minus 1. Finally, 3 minus 6, so minus 3. 4 minus 6, so minus 2. And 4 minus 3, so 1. Okay. So these are profit numbers. You see? I get minus 6 here, minus 2, minus 1, minus 4, minus 3. Then I get 4, 5, 2, 3. Then I get 1, minus 2, minus 1, minus 3, minus 2, and 1. I hope you guys understood what I did till now. I took every combination, starting with the first one for the buy, that is 7, and then 1, 5, 6, 3, 4 as the sell dates. Then 1 as the buy date, then 5, 6, 3, 4 as the sell dates. 5 as the buy date, 6, 3, 4 as the sell dates. 6 as the buy date, 3 and 4 as the sell dates, and finally 3 as the buy date and 4 as the sell date. And now we have every single combination of buy and sells, and we just compare the profits of them and see that, oh well, this is the highest profit I get, and boom, we get the answer. So for this, we will do, it's a brute force solution ideally. So you can see, right, if the size is of n, I kind of have almost like n into n plus 1 by 2 iterations. So you can have like n square, O of n square, kind of, because imagine this. I had 6 values I did like almost 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 is how much? 6 into, is it 6 into 7 by 2? Almost. 6 into 7 by 2 is how much? 21. But we did how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Right? Okay. Now, let's take a bigger case. Let's take a smaller case, sorry. If it's size 1, then it'll be how much checks? No checks. Right? Let's take size 2. 1 check. Size 3 will do 1, 2, 3, 4, 5, 6. So 3 checks. 4 will do how many? Let's take 1, 2, 3, 4 as the 4 digits. So it'll be 1 and 2, 1 and 3, 1 and 4. 2 and 3, 2 and 4. 3 and 4. So we have 3, 4, 5, 6. Okay. 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 Now if we do the formula over here, let's just say we use the formula n into n plus 1 by 2. What do you get for 2? You get tell me. Waiting. It's even better if you do n into n minus 1 by 2 over here, because you can get the, I think, accurate answer if I'm not mistaken. So if you see, it's 2 into 1 by 2. So you get 1. 3 into 2 by 2. So you get 3. 4 into 3 by 2. So you get 6. Right? So it's n into n minus 1 by 2. But that being said, the main point is, what I wanted to bring out is, it's n into n. N into n means it is O of n square. So number of checks you do for this algorithm is O of n square time complexity, and space would be O of 1, because we're not using anything special to store anything. Okay. We might use one variable or so, but not too much. But the main point is, its time is O of n square, which is never acceptable, but it's good to know. So we'll quickly write the solution. Okay. I'm going to start typing here. N is equal to length of prices. Then I'll do for I in range of n, and for j in range of I plus 1, comma n. The I represents the buy date and j represents the sell dates. So then future dates we want. So I plus 1 and till end. Okay. And what we do is, current profit is equal to prices of j minus prices of I. Then we'll declare one more value called max underscore profit, which is 0 initially. And at every point, we'll check the best maximum value. So we'll do max underscore profit is equal to max of max underscore profit, comma current underscore profit. And then we can just say return max underscore profit. If I run this, what happens? Boom. We do get the solution, right? Solution is there right here. And submit. And as you can see, we will probably face a time complexity issue. I'm assuming so, because LeetCode does like it to be a little bit better than this. Hopefully. We'll see. As you can see, time limit exceeded. Why? Because for values of this size, you can imagine the time it will take, right? So very important to optimize our algorithm right now. Okay. That being said, 198 out of 212 cases did pass. So it's actually a fine solution. It's just not a good solution. Got it? It is a solution. Very important to understand. It is still a solution. It's just not fast enough. So that's different. It's not optimal solution. It is a solution. Okay. So we got one solution right now. Now we'll think of ways to further optimize this. Okay. I'll just open my notes in case I left out anything quickly. Yeah, doesn't look like it. Cool. Okay. So next idea that we're going to go for, right, is using something called dynamic programming, right? In simple words, what we do here, right? Okay. In simple words, what we do here is use a previous value to get the next value. Simple as that, right? Use the previous prediction to get the next prediction. And one, I guess, kind of a very simple thing is like a Fibonacci sequence. You can think of it like that, right? You store all the previous solutions to get the next solutions, A plus B, previous A plus B, and so on, right? Anyways, we don't have to go too deep in that. We're not looking into the learning of what is dynamic DP as a whole. We're just looking at applying it for this logic. So what we'll do now is we will quickly go through the ideology over here, okay? So what we'll do is this. At every point, okay, you would track the maximum profit, okay? So at every point you track the maximum profit, okay, using the DP. And what do you have to do is, other than that, is that you need to, let me just verify something. I don't think my solution is that good, actually, what I mentioned here. I am not happy with that. Okay, I mean, it's fine. It's just that it'll help you to understand the concept of DP. I just think that, yeah, it's fine. Okay, okay. It's good. So we'll take a min price, right? At every point, what we'll do is we will minimize our price called min price. What is the purpose? Okay. We'll take the numbers 7, 1, 6, 4, 2, 3. Okay. At every point, we'll do two things. One is find the most minimum cell value at that point. So at this point, 7 is the minimum value. Then 1. At this point, still 1, still 1, still 1, still 1. This is, we'll call it as min price. At every point, find the minimum buying value. Okay, minimum buying price. And because we want to minimize it, right? So at every point, find the minimum buying price. Okay. And at every point, just calculate the maximum price that you can sell it for. So minimum price is 7. Let's say I just buy and sell in the same day, I get 0. Okay. Now minimum price is 1. I sell it with the current price, I still get 0. Minimum price is 1, but selling price is 6. If I sell, I get 5. Minimum price is 1. I sell it for 4. I get 3. Similarly, 1, 2, I get 1. 1, 3, I get 2. Got it? Now, one option is we can just maximize this. Okay? Done. Good to go. Another option is, at every point, this is the DP aspect to it. Okay? Which is unnecessary for this problem, but I still want to make you guys get the idea of it. So it's good to know. So at every point, what you will do is you will store the maximum price or the best selling price at that point. This is not maximum price, this is the current price. Okay, I'm sorry for naming it wrong. This is the current profit. At DP, what you will do is show the maximum price or profit at that point. At this point, 0. At this point, still 0. At this point, 0 versus 5. It is 5. 5 versus 3. What is the best option? 5. 5 versus 1. What's the best option? 5. 5 versus 2. What's the best option? 5. And boom. So at every point, we check the previous value with the current profit. Previous value, current profit. Previous value, current profit. Previous value, current profit. To get the final profit. I hope you understand what I said till now. There's two ways from this logic only what I did just now. One is maximize your current profit. Just find the maximum current profit. Okay. Another is at every point, find the maximum profit. First, what we'll do, check the current profit, current maximum profit, and check the previous maximum profit. So we'll get 3, 5, 1, 5, 2, 5, and then get the final solution. Again, if you didn't understand, let's take one more example just to go through two of the solutions because there's two solutions over here. I don't want to miss out. So let's just see that. Okay. So, okay. Let's take random values 8, 5, 4, 3, 1, 10. Okay, so we'll find the minimum price array. Minimum price at every point. So here it is 8. Here it is 5, 4, 3, 1, 1. What's the profit at every point? It is 0, 0, 0, 0, 0, 9. Okay. Finally, what is the DP aspect of it? At this point, the maximum profit I can get is 0. Now I'll compare these two to see, okay, still 0. Maximum profit in the previous possibility and the maximum profit in the current possibility is still 0, both of them together. Still 0. Still 0. Finally, 9 we reach as the best maximum profit. Compare those two, get the best value. That's all. Compare previous day's maximum profit with the current day's profit. If the current day's profit is more than the previous day's maximum profit, then choose that as the maximum profit. Got it? Of this day. And repeat like that. Okay? Or another solution was, just get this list of items, right? In that, maximize. You get 9. Right? That's it. So there's two approaches I'm discussing over here. One is compare to the previous day's maximum value to get the next day's maximum value. Current value, previous value to get the maximum value of the 2 days, right? And so on. If you want one more, I'll go through just to, make you understand a little bit even better. I'll go 8, 9, 5, 6, 5, 7 will go, 5, 7, 10, 15. And yeah, that's enough. Okay. So the minimum price here would be at this point 8. At this point, it'll be 1 sec. Okay. It'll be 8, then 5, then 5, then 5, and then 5. What is the profit at each point? At each point, okay? 0, 1, 0, 2, 5, 10. Okay? Well, if we maximize this profit list, the greatest value over here is 10. So answer should be 10. That is one approach. Another approach that we discussed was DP, where we store the maximum profit at each point. Okay? So at this point, it is 0. At this point, it is 0 versus 1. So it is 1. 1 versus 0. So it is 1. 1 versus 2, better profit is 2. 2 versus 5, so better profit is 5. 5 versus 10, better profit is 10. Finally reached 10. Okay? Of course, you can see that it's more less optimal for the DP solution, because even though we're reaching a 10 in one iteration, we're still having to do a lot of computations over there. Along with that, which is actually common, we do computation over there as well, so it doesn't different. But the main thing is we're storing every solution, right? We're storing every past solution. So you actually end up getting O of n space because of that. Because you see, I have n size and DP also has n items in it. I get 0, 1, 1, 2, 5, 10. But profit I don't store like this. I store it in a different way. Okay. In DP you store it in an array over here and do it up. Okay. So yeah. Overall, the main thing is, you gotta understand is, we're going to discuss two more ways here to solve this problem. And pretty much we'll go with the DP first and then go to the other one, because the other one is better than DP, and I want to discuss the time and space of the DP as well as the other one later on. Actually, we'll discuss that right now, not later on. Okay. DP, what do we do? At every point we check only once, right? No matter what, at every point we check the profit and done. That's it. At every point once. That's it. Done. So our time is actually going to be O of n, just as much as the size of the array. If the size is 6, we'll take 6 times complexity, 6 amount of time, whatever it is, for each computation. Okay. Similarly, if the size is 1000, it'll take 1000, which is much better than 1000 square. So our time is actually O of n for both solutions, but our space is O of n for DP and O of 1 for the max solution. So it's actually better to go with the max solution, what I discussed here, than DP over here. But but we still would like to know it. So I would definitely go with DP as a good challenge to learn things. Okay, so let's quickly reset this and write the DP solution here. I'll got as DP is equal to 0 into length of prices. Okay, for price in prices, because I need to go through every item only once. That's it. For price in prices, what do? We need to find the minimum at every point. So I'll store min price. I'll just store it as prices of -1, because anyways we're going to get that value in the beginning. So min underscore price is equal to min of current price with the old minimum price. Similarly, not similarly, sorry. Then you do is dp of we do need I actually. Fine. dp for I in. Okay, fine. N is equal to length of prices, and then we'll do N here, and then we'll do for I in range of N, and then what we'll do here is prices of I. Okay, and then what is at every point, what do we do in DP? We check at every point the maximum of I -1, okay, comma current profit, which is profit is equal to, I could write it there as a separate variable, but I think I don't want to make a new variable, so I'll just say prices of I minus min price, which is actually the selling buying price. Okay, at every point we just do this, but it's not done, because if you think about it, in the first point I don't have an I -1, so it'll give me error. So what do? You just put a small if condition saying if I is equal to 0, then dp of I is equal to prices of I minus min price. Okay. Else this. Finally, we can just do return of dp -1. Okay. So we did a lot of things here. Looks like I did one small issue here. Let me just quickly see. Output is 6. What did I do wrong? dp of I -1, 0, 0, 0. Prices of I minus min price. Min price is the minimum of this. Okay. Next to dp I -1. And price of I minus min price. Okay. So yeah, 7. Let's just quickly debug this. This is actually good. Actually, good thing for us. Just quickly debug this, or maybe I can just check the solution that I have in the site. That'll also be fast, I guess. You can just be like, well, okay. Price of I minus min price. Interesting. I think it's more easier for me to just debug like this and look at the solutions too, because I don't have my own solution right now, right? So let's see. It becomes 6 in the beginning. Why is it 6 in the beginning? Right? Because min price is price of -1, that is 7, and 7 is compared with 7, right? So should be print of min price. Okay. 1. Oh, I did price of -1 here. That's actually my bad. I should have done price of 0. Why did I do price of -1? My bad. Okay, so as you can see, this should be good to go now. Yeah. Price of -1 goes to the back of the array. So I put a wrong number there by mistake as the initial value. But if I submit this, I think there should be a solution. Yeah, as you can see, it is a fine solution. It's not the best solution because of some reasons, but it is a fine solution. And what do we do here? Let's quickly reiterate. N is equal to length of prices. Okay, so we have prices array, which is size is n, and then what do? We initialize a new array which represents the maximum profit at every point or every ith day. So dp is 0 into n. What does that give? It gives you an array 0, 0, 0, 0, 0, 0, 0 for n days, because we have n size array for prices. Finally, we initialize our min price, which is the buying price, the minimum buying price, with the first value. After that, we loop through every item one by one, minimize our buying price at every day based on the current day's buying price. At the same time, we'll also try to find the maximum profit that we can get for that day. Got it? Now, to compare the maximum profit of the next day, you just have to find the maximum profit for the last day with the profit of this day, right? Because we have the maximum profit of the last day, which comprises of all the previous days together. This is the maximum profit. So we already have that value. If we compare that value with our current profit, whichever is greater is the actual best profit, right? What I'm saying is we already have the best profit possible for the previous day in the DP value. All we need to compare is the previous day, which represents the best profit of the previous days, with the current day's profit. If those two you maximize, every step we maximize those, we get the best profit possible. That is the approach that we take here. But the point is, we don't need to store every single point's previous value. So we'll just simplify it by a bit by saying max underscore profit, as we discussed in the other one, is equal to 0. Okay. Return max profit will do. Okay. Min price will still fine, but the only logic I'll change is max underscore profit is equal to maximum of the maximum profit at that point, comma, prices of I minus min price. It's the same logic as a DP. Nothing different. Okay. But this time we don't use an array. That's all. Made our life more simpler, right? So yeah, that's one more solution. I just put it out there. Got it? You can see max profit, price of I, blah, blah, blah. This is O of n complexity. Okay. So it's pretty good, but definitely still needs, not still needs. This is good. This is very good. Okay. I think this is one of the solutions that we planned. Okay. Greedy approach is done. Okay. Okay. There's actually one more thing, something called Kadane's algorithm. I just feel that since the time complexity of that also will be O of n, that we don't need to go towards that. That being said, if you let me know down in the comment section whether you guys want to know about that, we can go for it. But this is actually a good solution for this one, where you do the min price, min profit, maximum profit, and go with that. So why is it a good solution? That's very important. Why is it a good solution? Why? Because it's O of n time complexity and O of 1 space complexity. We are not using any extra space that scales with the size. It's just two different variables, or three in our case. Three variables, done. Got it? We can of course optimize it a little bit more by saying we don't need n anymore. We can just say for price in prices. Then I can just be like price over here, then price over here, and then okay, that should be fine. Right? A more simpler code without using index and stuff. If you submit here, well, I mean, speed won't change in that side, but I just wanted to showcase that we can write it in different forms as well. We can probably write in other ways as well. I just wanted to showcase that there are different ways of approaching an algorithm, but different ways of the solution itself, but the approach will be the same. Okay. So what did we learn? Three algorithms right now. One is the min price, max profit logic. Other one is going to be DP approach. And the first one we learned was brute force, which is not at all a good solution, but it's a solution nonetheless. Okay. And those are three solutions for this problem, that is best time to buy and sell a stock. That is pretty much it for this session. That being said, I do want to quickly go over how to say the Kadane's algorithm in case you guys do want to do that. So what we will do instead, right? We'll use our trusty old friend, and quickly go here, right? Also maybe if you want to understand the problems, like always, just take this. Can you give some more examples to make me understand this? Always go through this. Always do this process. Reinforce your knowledge. Even if you understand, it's fine. You can do it. It's always good to reinforce your knowledge. Trust me. It helps out a lot. So you can see they give you the day-by-day analysis of this, what's happening. If you still do not understand from what, you can pause the video over here and read this as well if you guys want. And you can see, if you still don't understand what's happening here, we can tell it to represent in a different manner. So we can just say, can you represent it in a better form such that small child could understand? Let's just, we can do a lot of different things like that. That's what I'm saying. I'm just saying that if you don't understand the logic, the way I explained it, right? You can just put the code, ask it more different kinds of explanation. Got it? See this, right? I'm just saying, there's a lot of ways you can learn over here, reiterate over this. But that being said, what I wanted to know was, okay, we'll stop this here and say, forget about all that and explain to me about Aneesh algo for this problem. In case you guys are interested in learning the fourth solution for this, this is what I would advise you guys to go through. Okay, Cadence algorithm. What is it? Maximum sum of a sub-array in a given array. Okay, and what do you do here? Blah blah blah. You can see convert price into daily changes, and then apply Cadence algorithm. Okay, this would be the logic. This is what we do for this one. Okay, I'm going to go through this right now, but I just wanted you guys, if you're keen on exploring another optimal solution, then there's something called Cadence algorithm as well. Okay, that's all I wanted to bring into your perspective. In case some people use this in solution, so that's also possible. That's a very good solution as well. So just be on the lookout and enjoy overall learning process, and that's pretty much it, guys. So take care. Let's see you in the next episode, and that's it from me for this episode. Thanks.